A geomagnetic storm is a temporary disturbance of the Earth's magnetosphere caused by a solar wind, shock wave and/or cloud of magnetic field that interacts with the Earth's magnetic field. The increase in the solar wind pressure initially compresses the magnetosphere. The solar wind's magnetic field interacts with the Earth's magnetic field and transfers an increased energy into the magnetosphere. Both interactions cause an increase in plasma movement through the magnetosphere and an increase in electric current in the magnetosphere and ionosphere. During the main phase of a geomagnetic storm, electric current in the magnetosphere creates a magnetic force that pushes out the boundary between the magnetosphere and the solar wind. The disturbance in the interplanetary medium that drives the storm may be due to a solar coronal mass ejection or a high-speed stream, co-rotating interaction region or CIR, of the solar wind originating from a region of weak magnetic field on the Sun's surface. The frequency of geomagnetic storms increases and decreases with the sunspot cycle. CMR-driven storms are more common during the maximum of the solar cycle, while CIR-driven storms are more common during the minimum of the solar cycle. Several space weather phenomena tend to be associated with or are caused by a geomagnetic storm. These include solar energetic particle events, geomagnetically induced currents, ionospheric disturbances that cause radio and radar scintillation, disruption of navigation by magnetic compass, and aurora displays at much lower latitudes than normal. In 1989, a geomagnetic storm energized ground-induced currents that disrupted electric power distribution throughout most of the province of Quebec and caused aurora as far south as Texas.